let me give maybe a kind of summary, or maybe draw the conclusion out of all this. So what should we, or what have we learned from this? Is the conclusion that actually fixing, the choice of a fixed representation Hilbert space is not adequate. So if I'm looking on the CCR relations for a finite number of degrees of freedom, I know all representations are unitarily equivalent. So this means I can essentially fix one representation, and then if I change, if things change in time, or if I'm making a perturbation of one theory against the other, then I can realize all those things in the same Hilbert space, and I can relate those guys by a unitary operator. Okay, so this means fixing a Hilbert space once and for all is okay, and you can describe everything in this Hilbert space. Yeah, but if I go to infinite degree of freedom, this is not adequate anymore, because if I have a time evolution, or I want to compare two different theories, then each of them more or less has its own Hilbert space. So this means I cannot, by unitary mapping in general, relate the two Hilbert spaces. And this means I should not fix a Hilbert space and insist on doing everything in this kind of Hilbert space with the given representation. But one should change maybe one's attitude to a more algebraic approach by saying, so what describes the physical system is not a representation on the Hilbert space, but it's really given by the algebra of observables, and then different physical situations correspond to different representations. Yeah, okay, so this means this is more a shift to a more algebraic point of view. So not going directly into a Hilbert space and work out concretely everything there, but maybe look on the algebra of your observables and try to understand as much as possible on this maybe more algebraic level, and then for concrete theories, concrete calculations, one should go to an appropriate representation of the given algebraic situation. Okay, but of course, I mean, algebraic is maybe a too algebraic word, because one should not forget that actually one is always dealing with operators on Hilbert spaces. So it's not just the pure algebra which plays a role, but actually what one really should consider in this context is what so-called C-star algebra. So a C-star algebra generated by algebraic relations, and the C-star algebra is somehow the analytic version of the algebra of my algebraic relations, if I insist that those algebraic relations should be realized as operators on a Hilbert space. And so what I want to do next time is to be a bit more precise on this, and maybe in particular also talk about the canonical commutation relations C-star algebra, which corresponds to this. So this I will do next time. Yeah, but so maybe the conclusion here, okay, so maybe I should write down something. So the idea is that the physical system corresponds to an algebra of observables, but that different physical situations corresponds to different representations. Yeah, okay. But as I said, algebra should be taken with a grain of salt. And so what we really want is we want algebra where we still know or insist that we are working on a Hilbert space. So actually what we really usually consider there is a C-star algebra considered or generated generated by the algebraic relations which we are interested in. And so for us, the most interesting algebraic relations are the CCR relations, maybe in the form of the while relations, because C-star algebras corresponds to bounded operators, so we really want to have bounded operators, and this is given by the while relations. So we have a C-star algebra generated by the while relations, and this is something which maybe I will say more about next time, but here I just want to mention that this general approach maybe is connected with a couple of names. So maybe Siegel was one of the main proponents for describing physics in general, quantum mechanics in this operator algebraic language. And then there's also Haag and Castler also made this more precise, and there was much more in this direction. But I don't want to go much more into this. But I think next time, at least, I want, maybe just to remind you what a C-star algebra is. But then the main emphasis maybe is to say a little bit about the C-star algebra of the CCR relations. What really this is and how we can get it, and essentially how we can see that such an object really abstractly exists.